let's say 30 to 45 minutes, we will see. I will show you a bunch of things you can do with Cargo. This is probably, if you have written a lot of Rust already, I will not tell you so many new things. If you are rather new to Rust and you maybe just started with 1 or 2 Hello World projects, then I hopefully will be able to tell you a lot of tricks and behind the scenes stuff about Cargo and so on and so on. Before I go any further, I have posted the material, the link to my material, the slides, the samples, and so on in the GitHub and in the Discord channel. Everything is MIT licensed, so please take my slides, use them, share them, build on them, whatever you want. All the content that I will show you in my presentation is available. Oh, this link only works in GitHub Live. Everything will be available in Markdown, so take it and maybe translate it into whatever you want. And you have all the samples in the sample directory on the GitHub repository. Speaking of GitHub, this is the repository where all my material lives. So here you can see the slides. This was the link that didn't work before. Copy them, do whatever you want with them. And here you see all the samples. So if you want to recap things that I do here in this talk, take a look at this GitHub repository. And with that, without any further ado, let's jump right into it. And the first part, let me get rid of that one. I forgot to quit this. Yeah, now it's good. Okay, everything's fine. The first part will be for beginners. Okay, well, it will be for people who have not written so much Rust, but I hope even the first part will show the more experienced Rust developers some new tips and tricks. And then in the next chapters, we will dive deeper into Cargo. So first, let's quickly introduce Cargo. Let's keep that very short and to the point. It's a dependency management system. You manage your Cargo, your Rust dependencies. Dependencies are called crates. In Cargo, crate, we are here in a German spoken country in Austria. Crate is a Kiste, Holzverschlag. This is what a crate is all about. So when we're talking about crates, this is the name of Rust's dependencies, packages. But Cargo is more than just dependency management. It's also a helper to invoke the Rust compiler, the documentation generator, and so on and so on. So it's a tool that makes it simpler to pass all the necessary parameters to the Rust compiler and associated tools. So if you would like to start something from scratch, you just say Cargo new, and then you give it a name. Finally, you specify bin or lib, depending on whether you want to create a program or a library. Next, you go into the generated directory here. You call Cargo build, for instance. By default, this uses the profile def. You can define the details about different profiles with Cargo, but the default profile creates a debug version of your code. And then you can simply run it. And where can you run it from? The target folder. So if you run Cargo build, you will find a new folder, target. There you will find the name of the version you are generating, debug, release, whatever you are looking for. And finally, the executable. And here you see how you can run this one with Cargo build release. This now enables all the different optimizations and so on. And finally, you can run the release version. Please note here, the link here, if you want to fine-tune the different profiles for Cargo, take a look at this link. I only have 45 minutes or so today, so I cannot tell you everything about Cargo. You still have to do a little bit of research, but the least I can do is give you some links where you can read more details if you need that. Okay, this is a very quick introduction of what you can do with Cargo, but there is much more. Here I've put together a table with the most important Cargo commands. Cargo new obviously creates a new package, can be a library, can be an executable. Cargo search searches for a crate in crates.io. We will talk about this website in a second. Cargo tree displays a nice tree visualizations of all your dependencies, because you might depend on a crate that depends on a crate that depends on a crate, and so on. And this gives you a tree-like visualization. Cargo build obviously builds the current package. Cargo run runs the current package. So you do not need to type target and debug and name of the executable. Just type cargo run and you're done. I will show you that in a demo in a second. And finally, cargo fetch. Cargo fetch is somewhat important because sometimes if you are traveling a lot, well, not now in times of Corona, but later on when you travel a lot, like me, for instance, and you would like to work on your project while you are offline, maybe on the plane or on the train or something like this, just call cargo fetch. It will fetch all the dependencies from network. And that means you can later on run cargo run and cargo build without ever touching the network. So cargo fetch is important for people who are traveling a lot. Good. That brings me to the typical file layout of a project. Let's zoom in here a little bit. Here you see one important file that we will work on a lot in the upcoming 30 minutes or so. It's the Cargo.toml file. They define some metadata about your application, the author and the license and a lot of other stuff, and of course, your dependencies. Once you call, for instance, cargo build, a cargo log file is generated. Maybe the Node.js developers, does that sound similar to what you already know? Yes, Cargo.toml is very similar to package JSON, and cargo log is very similar to package log JSON. So the cargo log file is generated by the cargo tooling when all the dependency resolution is done, and cargo log contains a lot more details about the dependencies, the detailed versions and the dependencies of the dependencies and things like that. It is responsible for repeatable builds. So if you just take Cargo.toml, you don't get a repeatable build, but if you take cargo log, you can really ensure repeatable builds. And also it makes the tooling faster. On the same directory level, you also have your source code. It's here. You can add some benchmarks. Yes, Cargo and Rust have a benchmarking mechanism built in. You don't need third-party tools for that. You can add examples. And I personally, when I got into Cargo, I found this one a very interesting one. There is a dedicated mechanism of adding example code. You know, this comes in very handy for me. When I build libraries, then I typically do a kind of, let's say, example-driven development. I design my libraries while I am thinking about different scenarios that my library should fulfill. And now I can write the example code in the same folder structure, and it fits in nicely into the whole project structure. I really find this one very interesting. And finally, here we have the tests. But important one, it's called tests, but it doesn't mean unit tests. If you read tests directory, it means integration testing. I will show you later an example how a unit test looks like and how you can run unit tests with Cargo. Okay, let's talk a little bit about the Cargo.toml file. I already mentioned it's similar to NPM's package JSON file. If you have never written JavaScript or Node.js or TypeScript code and you don't know what package JSON is, don't worry. You don't need to know that. But those of you who have, you know what I mean. The file has to be called Cargo.toml with an uppercase C. That's defined, okay? TOML, it stands for Tom's Obvious Minimal Language, short TOML. You can follow the link here in my slides. Just go here and you can read all the details about TOML. I think it's very obvious. Everyone can read it. It's super simple. That's it. Just remember, the file has to be called Cargo.toml, not anything else. It's built on semantic versioning. So if you add a dependency to Cargo.toml, you also add the version number of the dependency you would like to depend on. And this is built on semantic versioning. So again, here I added the link. If you have never heard about semantic versioning, that is my homework for you. Read this document. Semantic versioning is super important in every modern programming language that I know. Okay, so here is the link. And everything is built on semantic versioning here. You also have some package metadata, and it looks like this. This is typical package metadata. It's the name of the package, the version, the author, and the edition. The edition is something that that beginners with Rust are sometimes a little bit confused. The edition is not your edition of the library. It's the edition of Rust that you would like to work with. And 2018 is currently the latest stable release that you can use. And down there, you will find some dependencies. We'll talk about that in a second. The cargo log file, again, similarity to npm, package lock JSON. It's maintained by Cargo, so leave it alone. Do not touch it. Do not write to it. Well, you can take a look at it, but never write to it manually. One question that comes up very frequently, should you check in the log file? Well, it depends. If you build an end product, you typically care for consistent builds. You would like to build an end product that really has specific dependency versions baked in, and then you check in the Cargo log file. If you are creating a library, you typically do not check in the Cargo log file because the choosing of the detailed version is done by the end product using your library. If you're not confused, well, take a look at this link. Here you can find all the details in the Cargo frequently asked question lists. I don't have the time to go into further details, but just remember the rule of thumb: end products, check it in; libraries, don't check it in. Then you are typically out of the problem space. With that, let's take a look at my first example. Just to let you know, my examples here are written in a kind of hands-on lab style. I always do that when preparing some talks. So you can take these hands-on labs for your own practice. Just don't take a look at my solution. Just try this hands-on lab and solve it on your own. You can take a look at my solution if you are stuck somewhere. But if you are doing, for instance, in your company, Rust hackathons, or if you are a teacher and you would like to teach some lectures about Rust, or if you are a trainer giving a Rust training, take a look at my hands-on labs. Feel free to copy them, to extend them, do whatever you want with them, okay? But I will now walk you through this example because we are sitting here together. And let me quickly start Visual Studio Code in my samples folder. And here we are. This is the sample, this one, the 01 intro. This is a sample that I would like to show you, okay? The code is very simple, and let's start with the Cargo.toml file here. The important stuff that is going on here is in the dependency section. As you can see it here, I have two dependencies. One is regex, because this sample does something with regex. And the second one is lazy static. Lazy static is an interesting dependency. It allows you to initialize something in a lazy fashion, but statically. So in my case, I would like to compile a regular expression, but only once. And every time I execute the code again, I would like to access the compiled regular expression. And this can, for instance, be done with this package. If I hover over this thumb, I see all the different versions of my dependency. To be honest, this is an extension here. I will not go into the details. You will probably find it on your own. If you just take a look at the extensions in Visual Studio Code here and just type in cargo or crates, then you will find a lot of extensions. In this case, it's a quite handy extension because it shows me all the different versions. And if I do something like this, if I'm using an outdated version, it immediately tells me that I'm out of date and the latest one would be 1.3.9. Okay, now good. Thumbs up again. If we take a quick look at the source code, you see the source code is pretty standard. At the beginning, I'm using a standard IO. This is part of the Rust standard library. You don't need to add an explicit dependency to Rust standard library. It's always available with some exceptions. I know it. It's possible to program without it, but that would be the exception of the rule. Generally speaking, you always have a dependency on the Rust standard library. You don't need to add that to your TOML file. Here we see the two use statements, which refer to the dependencies that we have added in our Cargo.toml file. And this example is pretty simple. In an endless loop, I'm asking the user to enter some text. If the text is quit, we will stop the program. Otherwise, I'm going to call this method down here, is proper date. And here you see, here I'm using the lazy static macro, which allows me to lazily compile for a single time the regular expression. And then I just call the isMatch to tell the user whether he or she has just entered a valid date. Let's try this application. First, I'm going into the folder and I say cargo build, this will build my application. I consciously deleted my target folder. So therefore you see what's going on here. It's fetching stuff from crates.io and it's now building, compiling the dependencies, and it's also compiling my application. Now it's done and I can just cargo run it. And here you see, I can enter something. This is not a date, but if I enter something like this, it says it's a date. So the application is working. We have two dependencies in our Cargo.toml file, and we have seen how Cargo helps us to build the application. In this case, in a debug version, I could now start the Visual Studio Code debugger and set a breakpoint and things like that. This is what Cargo in a nutshell does for us. If we take a look here in the target folder, then you will see that we find a lot of interesting stuff here. And here you essentially see where the dependencies are stored, or at least versions of the dependencies are stored. I will not go into the internal details, how this stuff is stored in details. To be honest, I don't absolutely know what's going on behind the scenes, but at least you can see that the dependencies are here in the target folder. Okay. Good. First sample. Let me check if I did everything. Yes. Okay, good. Next one. Workspaces. Workspaces was, they were something new for me as a JavaScript developer, partly as a C# developer. I spent most of my work working with C#, JavaScript, TypeScript, and all this stuff. And workspaces are a really neat thing. What you can do is you can create a collection of more packages in a kind of folder structure. For instance, if we take a look at my samples folder here, this is in fact a workspace. You see, we have on the top level here, we have a separate Cargo.toml file. You see that one? So if I check the Cargo.toml file here, we see that we have some members. So my samples workspace consists of multiple, in this case, binaries or even libraries, and they are commonly maintained inside a workspace. And the important thing here is that they share a common output directory. You can see it here, target. So what I can do is I can cargo build all my projects in all my subdirectories which belong to my workspace with a single cargo build. I happen to add a unit test in one of my libraries, so I can also call cargo test. I will tell you more about that in a second, and run the unit tests. Let the system just quickly finish compiling all my code, and you see it will look into all the different projects which are part of the workspace. And in this case, one of my projects here contains a unit test, and luckily it passes. Another important thing is that you have a central Cargo.toml file, so they share the same dependency resolution, so they share a cargo log file. That means that if you have two different libraries and they refer both to, for instance, something like rand, the crate for random number generation, then both of them will rely on the same version. The system will pick the same detailed version of this dependency for all the libraries inside this one workspace. So this is what workspaces are all about. And here I have added the GitHub link where you can take a look at my samples workspace. That should be enough for getting started. And now we can dive a little bit deeper into dependencies and what you can do with dependencies. And believe me, if you come from the JavaScript world and you have done a lot of package JSON magic, then you will now recognize even more magic, which is going on in Cargo. Cargo knows a lot of very interesting tricks here. As I said, dependencies are called crates. And here you see that this is the German Kiste, Holzverschlag, okay? So where can I get my crates from? First, and most commonly, you get them by specifying a simple version number, and that means that you get your crates from crates.io. If we take a look, this is crates.io, and here you can look for a specific crate. Let's check, for instance, this one. It's the random number generator, and here you see you get a bunch of description. You can take a look at the detailed documentation. You see the dependencies, you see the repository, the project can specify a homepage, and so on and so on. So this is by just specifying a version. I will show you details later on. What if you have some private libraries that you don't want to share publicly? You can set up a custom registry, and all you need for that is just a Git repository. At the end of the day, the Cargo tooling, it can get your crates from any arbitrary Git repository that you have inside of your local area network, for instance. So it's super simple to set up a custom registry. There are also offers, third-party offers, for instance, from Cloudsmith, where you can rent some private crates repository space in the cloud if you want. I've added some links here. Again, follow the links and you can read more details. But now comes the interesting part. We can also pick some crates directly from Git. So we can, instead of specifying a version, just specify a Git link. And then the Cargo tooling will Git clone the repository, look for a Cargo.toml file there, compile the whole stuff, and add it as a dependency to your application. So you can have a direct Git dependency using Cargo. Same is true for local folders. You can add a path dependency instead of a version number, and then the Cargo tooling will look into this path. And it becomes even more interesting. One additional thing that I have for you is you can specify multiple sources. And that becomes very interesting because then you can, for instance, say, Cargo, you know what? By default, take this version from crates.io. But if I also have a local version of my library here inside of this path, take this path if I run it locally. That means that I can work on a local version of my library, which is not published to crates.io yet, and I can override the dependency with a local version where I can maybe add some bug fixes or additional functionality. It becomes pretty simple to work with libraries while you are pulling it up, while you are working on this library, and overriding some sources which later come from, when everything is done, from crates.io. That's the idea of passing on multiple sources. I will show you an example later. Now we also have different dependency types. This is pretty obvious, so I will keep it short. You have dependencies, regular dependencies, you have def dependencies. They are only used for compiling tests, examples, and benchmarks. And then you have build dependencies, which are only used for build scripts. Build scripts are nothing else than Rust programs, which are run by the Cargo tooling during building your Rust application. This is what build scripts are. I will not go into the details for build scripts. Please look it up in the documentation. I simply had to skip some things because otherwise my talk would have taken 4 hours. So, simple ones. Referencing crates.io. Here you see some references to crates.io. Random number generators, number of CPUs. I want to find out the number of CPUs, and number formatting. Very, very simple. And here at the end, you have some version selector. And this is what I would like to talk a little bit about, how this works. I already showed you this example. Publishing crates will be an example at the end. Version references, as I told you, are based on SemVer. That means the first thing that you can do is very similar to JavaScript and Node.js. You can have so-called caret requirements. Caret is this nice little character here, and it just gives you the latest minor version for the specified major. So in this case, it gives you something between 1.2.3 and 2.0.0 excluding. So 1.x.x, this is what a caret requirement does. The tilde requirements, tilde is the character here, is similar, but it only works here on the minor version. So if you specify 1.2.3, you get something between 1.2.3 and 1.3 excluding. So you get 1.2 star. You can also write some wildcard requirements. I think it's pretty obvious what 1.star does. And you can also add some comparison requirements, something like greater equal 1.2.0. That's possible too if you want to use that, because caret and tilde requirements are too complicated. This is maybe easier to read. But be aware, there are some limitations. If you would like to publish your crate on crates.io, you can't use parts of the comparison requirements and wildcard requirements, if I can remember that correctly. So check that out. Maybe you will get an error with the caret requirements and the tilde requirements. You are on the safe side. Good. Now what's going on behind the scenes? What is this crates.io? Essentially, crates.io is a big index in GitHub. You see, this is this index in GitHub. So here you see the first two letters of all the different crates which are available on crates.io. For this talk, I published one on my own. It's called MTH calc for multi-threaded calculation. So let's look here in MT, and here I find the H underscore, and here it is. This is the example that I published for this talk, I think somewhere last week, and here you see the different versions of this MTH and so on. This is the index of all the crates. Okay, so and if you want to build your own custom crates repository, then you have to set up something similar. But of course, checking all this stuff inside of Git repositories is not very convenient. Therefore, a fully blown crates repository like crates.io offers a RESTful web API with which you can look for crates and find also their download locations. So there are just tarballs at the end of the day. So if we take a look at this one, for instance, this is a very simple give me all crates query that I sent here, and you see all the different crates with some download links and so on and some meta information. You can also pass in some queries. For instance, I've done that here. You can see, I go up here. Again, I'm looking for the sample crate that I created for this talk. And the second one happens to be exactly my example crate that I published 2 days ago. And you see, yeah, it's just a demonstrating cargo, and it was published by me, and you see that here. So this is what crates.io is behind the scenes. It's a web API on top of a package index stored in GitHub and a bunch of tarballs sitting somewhere on the internet. In the Cargo documentation, you can find details about how to replicate the whole package repository. If you want to have a copy in your own local area network or things like that, please consult the documentation if you would like to do something like that. With that, let's again take a look in another example. We will focus on the cargo stuff, but it hopefully contains some interesting stuff for you too. So what I did here is I made a mistake consciously. You see here, I was specifying a tilde requirements, which tells the system essentially, give me something 1.0 anything. And now my tooling tells me, hey, Rainer, there is already a 1.13. So what I can do, for instance, I can do something like this. Change that to a caret requirement. And what did I tell you? This will now give me the latest 1.x dependency. So now my tooling tells me everything is fine. You will get the 1.13 version of this library. Sounds good. Let's take that one. In that case, I'm having here a random number generator. I'm asking for the number of CPUs and I'm doing some number format. Essentially, what I did for this sample, it's very similar. I calculated pi. I like to do that. I like to calculate pi, but in a very special way. I'm doing a Monte Carlo simulation to calculate pi. If you're not familiar with Monte Carlo simulation is very simple. If I ask you, what is the probability to get a 3 if you're rolling a dice, you will probably say 3/6, right? Of course, but if I give you a real physical dice and you are not sure whether it was manipulated and I ask you the same question again, then the only thing you can do is let it roll a lot of times, count the results and apply a little bit of statistics. And this is what this example does. It takes a normal circle and a unit circle with the radius 1, takes a lot of random points and calculates the ratio of points within the unit circle and outside of the unit circle. And this ratio multiplied by 4, if you only take a quarter of the circle, is pi. This is Monte Carlo. And of course, this is a problem where you can do a lot of multi-threading. So I thought it would be interesting for you to see how we can, for instance, use the multi-threading stuff here. Here I'm spawning some threads, but the important thing for my talk here is that we are here accessing the libraries where I edit the references in my Cargo.toml. Here you can see I'm referencing the random number generator, here the number format, and here the number of CPUs. And what I do essentially here is I'm spawning as many threads as I have CPUs, and I'm generating a lot of points, and at the end of the day, I should get something in the ballpark of pi. So this is what this stuff really does. Want to see it working? Well, I hope it will work. Let's see. Let's go into this folder here. Let's do a clear and say cargo build. This one, pretty fast. Why was it fast? Can you remember what I did a few minutes ago? I compiled the entire workspace. Cargo is smart when it comes to incremental building. It recognized that nothing has changed, so it is super fast, and we can immediately Cargo run the whole thing, and it's now running for a bunch of seconds, and at the end of the day, woohoo, I get 3.1418. It's not pi yet, because I only did 7 million or 8 million calculations per second, but still it gives me something near pi. But I want to show you the same example with cargo build release. I heard Ryan talking about the difference between debug and release version, and I would like to demonstrate that here with this performance-oriented example. Let's release build it. Of course, it has to rebuild all my dependencies, now optimized for performance. And now we can cargo run it again. Cargo run. And in this case, oh, sorry, of course not like this. This is much better. Do you see the difference? Now this is the difference, right? 1 billion calculations per second compared to 8 million calculations per second. So this is what Ryan meant when he said, don't forget to compile your stuff in release mode, because there is a huge difference between Rust and Cargo building for debug versions and Rust and Cargo building for release versions. This is what I wanted to show you here, just to highlight some Cargo features. Now we have the dependencies and we have the release builds. This was this example. Now let's take a look at something which is less obvious. This is now a path dependency. What if I take my feature that I can run a certain mathematic algorithm in parallel on all my CPU cores and put them into a separate library? And this is what I did here. I took out one function of my application and I have put it into a separate crate, in a separate, no, not a crate, in a separate package, which is a subdirectory of my Cargo.toml, which is the binary that I would like to be able to run. Here you see it has its own source directory, it has its own Cargo.toml file, and here you see the implementation of my library. And here I am referencing exactly this path. So I'm getting the library from a subdirectory. Let's take a look at this example in real life. Here it is. Here you see I have my Cargo.toml with the path here. And if I zoom in a little bit, then you will see that this path points up to here. If I open this one, here I have the implementation, and here you see the dependency of my library. It needs the number of CPUs. This is no longer a dependency of my binary, which calls my library, because the binary is not interested in the number of CPUs. That's an implementation detail of my library. If we take a look at the source code, this is what I did. And please note, this is what Ryan already mentioned. This is how you add unit tests to your libraries. I'm now not talking about integration tests. I'm talking about unit tests. So in this case, I refactored out a helper method run on all CPUs. I will not go into the details of the implementation. All it does is it gets the number of CPUs on my system. It spawns the exactly same number of threads. I know this is not perfectly optimized, but I think you get the point. And at the end, it aggregates the results by iterating over the results of the thread and returns the result and the number of CPUs. That's all it does. And here at the end, I have a unit test for that. So let's play a little bit with this example here. So I have to close it here. Okay, so let's go into my folder here and let's cargo run the application just to make sure that it still works. It calculates pi slowly because it's debug, but it calculates something near pi. If I say cargo test, and that's the next tool that I wanted to show you, this one, it runs no unit test because I'm now not in the workspace folder, I'm in the binary folder. But if I go into the library folder here and run cargo test again, everything is fine. My unit test was run. And this really works. Let me quickly do something is lower than one or lower than the something like this. Let me see if I can screw it up. No, it doesn't make sense. Okay, I will not do ad hoc changes to you can try it on your own. It really executes the test. It really works fine. So what you have learned here is these path dependencies. They are really convenient when you split up larger applications into libraries. And now I think you get the idea. By combining the version number with the path, you can easily override a dependency while you are developing the library locally. Okay, so yeah, I already showed you this example. This is how a Git dependency looks like. And it happens to, I happen to have this example here. This is exactly the same application that you saw before, but now I have my small little library. I pushed it onto GitHub. So it's available here. You can take a look at it. It's exactly the code that I've shown you. And now I'm having a Git dependency in my application. I no longer have this subfolder here on the same level. I'm having a Git dependency. Let me show you how this works. Let's go into this folder here. And if I say cargo build, it will build everything. And yeah, if we delete the target folder again, let me quickly do that. Let me see if I have a target folder here and run it again. Exactly. And let's wait for another few moments. Yeah, everything is compiling. And once it's done, yes, I can show you this one. See? It automatically pulled, in this case, the latest commit of my implementation from GitHub and compiled it on my machine on the fly. This is what we have here in this Git dependency. This is pretty neat. I liked it when I discovered that, looking into the details of Cargo. Yeah, I already showed you that one. There are some advanced topics which I cannot cover because in the last, let's say 15 minutes or so, or 10 minutes, I want to show you something completely different. These advanced topics, you will probably not need them when you get started with Rust, but over time you will need them. So I would like to tell you how this works. This feature, I already mentioned it multiple times. So this is how you would write it in your toml file. You specify a version number. This version will be taken if you publish your library as a crate to crates.io, but you can have a local version of the dependency in a certain folder and therefore have some additional debugging capabilities and things like that. The next one is overrides. Overrides are even more advanced as this specifying multiple locations in this area. If you want to know all the details about overriding, if you want to go all in into library development and you have to develop patches for your libraries, definitely check out overrides. I added the documentation link here. Please excuse that I will not go into details here because of time limitations. Finally, you can also have platform-specific dependencies. So in this case, if your target and if you build the target with the configuration Windows, you might have different dependencies than if you target, for instance, Linux or something like this. Features are interesting. Your dependencies can have optional parts which are called features, and if you have a dependency on a library which offer features, then you can add, opt in or opt out from these features, and depending on that, the package behaves differently. Maybe you have a certain package which can optionally offer some features to convert something to PDF, but you can opt in or opt out of this feature. Maybe you don't need PDF support in your binary, then you can opt out from this feature. This is what optional dependencies and features are all about. And finally, build scripts. Build scripts are great. They are essentially a Rust application, a specific file, build.rs, which is in the root of your package folder. And this build.rs file is compiled and executed before Cargo is building the package. So you can do a lot of crazy stuff in this build.rs file. You can, for instance, build some C dependencies, C libraries. You can generate code on the fly. You can in code, find out some platform-specific configuration settings and change them before you apply these settings when you compile your package. So this is what build.rs is all about. Please check out the docs if this sounds interesting for you. I will turn on the light so you can see me a little bit better. Good. We have, I think, something like 10 minutes left, and I would like to go into my last big topic here for the last 10 minutes, and that is publishing crates. What if you create a library and you would like to share it with your peers, you would like to share it with the world? What do you have to do? First, you need to learn some new cargo commands: cargo login, cargo package, and cargo publish. Not that much. Of course, with cargo login, you can authenticate against crates.io. With cargo package, you can build your library into a tarball, and with cargo publish, you upload everything to the registry. Now, what do you have to do if you would like to publish a crate into crates.io or your custom crates repository? First, get an API token from crates.io. Yeah, I think that's simple. Then add some meaningful metadata. Add a README file, things like that. Add your name, a description, and I think you get the idea. Finally, if you want to be a good citizen, add some unit tests. Maybe optionally, add some integration tests. Add some benchmarks. Add some example code, something like this. Depending on the necessities of your libraries, you have to invest more or less time in these areas. At least you should add a bunch of unit tests. Document your API, including examples. And I will show you more about that in a second when we go into my last hands-on lab. And finally, you use Cargo to publish everything. The first step, you can see it here, is you run a dry run version of Cargo publish. Dry run means that it does everything except really publishing it. So you can check your package, your setup for potential failures. You can check the content of your package by doing cargo package -- list. It will show you what's in your package. Of course, we want our package to be small, and therefore we want to check out whether really only the necessary things are inside of our package. Maybe we have added some larger, let's say, text or HTML files which shouldn't be part of packaging. Then we will recognize a mistake like that. And finally, you upload everything using Cargo publish. This is the workflow that you have to follow. With that, let's spend a few more minutes in another example that I have prepared for you. Let's open Visual Studio Code with this version of my great mathematic multi-threaded calculation library. I know it doesn't make so much sense, but I thought it would be a good idea to have it here. So this is now a crate that I would like to publish on crates.io. I already have published it, so I can show it to you in a second. This is what the .toml file looks like. Obviously, I added a bunch of more metadata. I don't think that I have to describe all the things here. You can take a look at my GitHub repository or read the docs. These are my dependencies. I don't have to talk a lot about that. In this case, I get a warning that I already would have a 1.13, but it happens that I'm fine with that. But now comes the interesting stuff. In my example code, I will show you that in a second, I have an example that describes how to use my library, and this example is using a random number generator. In that case, I'm not adding a dependency, but I'm adding a def dependency, because this is something that my final version of the crate does not depend on. It's only the examples. You might ask yourself, hey, Rainer, examples? Aren't examples just documentation? And that's a big wow, that was a big wow effect for me as somebody who was new to these features of Cargo. Example code is executable documentation. So let's go into that one because I think it's really, really great. If we take a look at the library, then you will see that I have some example code here inside of my structured documentation of my function. And believe it or not, I can run these examples. I can build these examples. I can even add, here you can see that one, hidden code which contains unit testing code, which will not be part of the documentation, but it helps me to verify that all my documentation examples still work. Let me show you that. Let me show you how this looks like. I can do the following. I can say cargo test dash dash doc, and that is now running my embedded code here in my documentation area. So for instance, let's say if it's smaller than 1, something like this, doesn't make much sense. Let's run it. And it crashes. Yes, it crashes. I now ran parts of my documentation using the Cargo toolset. And the same is true for building this stuff and all these things. So this is really nice. And if again, now you understand what I meant with def dependency, because this dependency is only used inside of my documentation. You see it here. This is part of my documentation code. Now, what else can we do with this stuff? If we have nice documentation, we can run cargo doc. If we run the cargo doc, then we get, let me quickly open this one here in Explorer. If I go into target and here into doc, I will now see here an index.html, and I will get a nice little human readable documentation about my crate. If I go here, you will see the documentation from my Rust file. And here you can see this nice little example. This is exactly the example that I showed you a few minutes ago inside of my Rust code. Okay. So Cargo Doc is a built-in API documentation engine, which comes in really nicely if you are building reusable libraries, because we all know that a library is only as valuable as its documentation, because if you have no documentation or poor documentation, how should people find out how your library works? And I think this is really nice. Well, obviously, you can also add some unit tests to your library, just as we had before. I will not go into the details here. So if we now run cargo publish dry run, this one, yep, everything is good. It builds it. Yes, and fine, you see, no mistakes. If I would have some mistakes, for instance, if I would have forgotten some mandatory metadata in my package section here, I would have gotten an error. And if I leave out the dry run, it really publishes everything on crates.io. And this is what I already did. So if I go to crates.io and I'm looking for multi-threaded calculation, this is the example that I created for you, then you will see this is now the content of my README file. Here you have all my meta information that I added to the Cargo.toml file. I can go to the documentation, and that leads me to docs.rs with the name of my crate, and I didn't have to do anything for that. It was done automatically just by uploading my crate to crates.io. It automatically generates the documentation for me and publishes here on docs.rs. And here, just to prove the point, you see the public documentation of my sample calculation here. So this is the result of me publishing my crate from a different GitHub repository. Okay, so here you see the README file with the documentation and so on. I hope this one was interesting, so you get a better idea of what it takes to publish something on crates.io. And I was able to show you a bunch of, well, not so obvious stuff that Cargo is capable of doing, like, for instance, running tests, running the example code, even executing unit tests inside of the example code. If you are interested into more details, please take a look in my GitHub repository and in my slides and the hands-on labs. So we are already at the end of my talk, and let me quickly do a summary before we open it up for Q&A. First, Cargo is an indispensable tool for Rust development. Cargo is your friend. You will use it every single day. If you come from a world of JavaScript and TypeScript like I do, probably the basic features of Cargo will not be difficult for you because you will find many similarities with a node package manager. For me, as somebody who was new to Rust a few months ago, I detected some unexpected features, like for instance, the nice integration of the documentation engine and things like that, which I wasn't expecting from a tool like that, but now I really find them very, very interesting, and I would love to have things like that in other programming languages that I use too. There is some room for improvement. However, my most important point of criticism here is that it's rather hard to set up a custom package repository. I work a lot with enterprise customer. This is my daily business. I earn money by helping companies building great software. And many of these companies, they have some intellectual property which they don't want to share with anybody. It could be easier with Cargo to set up a custom package repository. If I compare that with what I'm used to from C# and JavaScript, there all of the major Git servers, for instance, they come up with some out-of-the-box support for a node package management repository, for a NuGet repository, and so on. You have a lot of great cloud services where you just, with a click of a button, you create a private repository, and this is unfortunately not that widespread in the area of Cargo and Rust. So you have to do a little bit of tweaking, hand tweaking here, or maybe select one or two offerings which are not that well documented yet. So this is room for improvement, but I hope that as Rust gets more widely used, we will find these improvements here. With that, I hope that you enjoyed the last, I don't know, 3/4 of an hour, something like this. You learned something new. You got my material, and we can open it up for questions if there are some. Stefan, did you take a look at the Discord server? Do you have any
constantly.
questions?
The Discord server is again flooding over with lots of interactions from the community. So I'm actually enjoying that a lot. So people are writing, people are discussing during your talk. There were a lot of things people have seen for the first time, even if they're long-term Rust Cargo users. Especially the doc feature was very new to a couple. There was one question from Sayan. I hope I pronounced your name right. If you go to your first example on line 38, so very specific line. Yeah, so there is static ref RE colon. And Sayan wants to know if you can explain a bit on how the RE defined in sort of scope is available outside. So
it's a static variable. It's a static variable which is available throughout the entire lifetime of the application. So what essentially lazy static is doing, when you enter this code for the first time, it initializes this static variable. And when you enter this code for the second time, it will not reinitialize everything again. So therefore, if I reference this RE variable here, it's just a variable, I get the compiled regular expression which I got when I called isProperDate for the first time.
All right.
I hope I described that good. Just Google for static refs, and you will find more detailed information about that.
As far as I can read it from the chat, it was also Sayan's first guess in that, and I think you answered it correctly. Other than that, there were a couple of questions, but the community answered it on the go in the chat, which is very cool.
Love that.
I guess you have a couple of things to look up, and with that, so Sayan says thanks for the explanation. Smiley face.